Hello everyone, my name is Evelien Schellekens. I'm a solutions architect at Elastic. And today I'm excited to talk to you about RAG, Retrieval Augmented Generation, and vector search with Elastic. But before we get started, let's look at an example on how search has evolved throughout the years. When we are thinking about the question, for example, how far is the moon from the Earth, we were used to searching keywords. So we would put distance moon, and then we would get web pages that have the answer. And if we're lucky, it's already in a snippet shown on top. If not, we have to double-click, find the answer we're looking for. If we have a follow-up question, we have to go back, ask again, and so on. Now, with the rise of Gen AI, search has completely changed. We can now search just in human language, how far away is the moon? And we get an answer back in human language. It's generated specifically for our question. If we have any follow-up questions, we can just ask it and chat about it. So it has completely changed the way we search. So I would say it's not only an evolution, it's a revolution. It has changed how we use search, but also how our users expect a search experience to be. So this is cool, and the LLM can answer questions about things that won't change, like how far the moon is from the Earth. But what if you want ask some questions about real-time data, company-specific data? Then the LLM needs to be grounded. So it needs to know this context before it can give you a relevant answer. And that's where Elastic comes in the picture. So as you can imagine, there are a lot of use cases for this, and it's not just imagination, it's already here, it's already running in production. Here are some of the examples. So for example, an HR help desk, where an employee can ask questions without having to send an email to HR and without HR having to email back on questions they get all the time. So the LLM, in this case, can have the context of the internal company policies and help with this question. Another example is customer support. So instead of having to call and wait in line for 30 minutes, you can just ask a question. This will, for example, be searched through the documentation of the product, some knowledge base the product has, and so on. And the last example is e-commerce. So instead of having to search for a product, for something you need, you can just tell what you want to do, and it can explain to you, okay, you need this, you can find it here, and this is how you can use it. So as you can imagine, these have all kinds of benefits. One of them is increased productivity. So not only does the employee not have to write an whole email to HR, there's also HR that doesn't need to spend time responding to all these emails. We also have more self-service options for our customers, so they don't need to call the support, so you need less support staff, and customers are also happier in general because they actually find what they're looking for. They don't get frustrated because they get weird recommendations. So it's a win-win for all people involved. And there are many, many other benefits for these use cases as well. At Elastic, we believe in to eat our own dog food, or we like to call it drinking our own champagne. So we do use our Elastic search capabilities and our integrations with LLMs to provide this experience to our customers, both in the Elastic AI Observability Assistant as in the Security Assistant. What can this assistant do? It can give a summary about all the alerts that are going on, explain to you what are the things that are happening in your infrastructure. And you can ingest any data in Elastic, so you can also give it the context of your GitHub issues. So in this case, it can tell you, hey, this is an issue that we know. We're actively working on it. And it can also explain, if you upload the runbooks of your company into Elastic, it can also help you how to remediate certain issues in certain services. And one fun fact regarding the AI assistant, when we were building this, we did some initial user evaluations, and we saw that there was one question that was asked way more often, and that's hello. And the reason is users don't really know how to interact with your LLM, so the thing we can learn from this is provide some quick prompts, like suggestions, give some examples on what you can do with the AI assistant, and so on. So to recap, RAG stands for Retrieval Augmented Generation, and it's by providing relevant documents in the context window of an LLM that's trained on public data. It can actually answer questions on your real-time data, on your private data, and so on. And that's, of course, where Elastic comes in. We can help you make sure that you can securely search your own data. We can make sure only the relevant context is given because you have a limited amount of tokens. And by things like semantic search, you can optimize this experience and make it also very easy to build these kinds of Gen AI apps. So Elastic is not just a vector database, so you can store embeddings within Elastic. You can search through them. You can also generate embeddings in Elastic, but we can do way more than this. So you can do hybrid search, you can do filtering. We have document level security, you can search on geodata. There's all kinds of stuff. So everything you need to build this kind of search experience, it's there. Okay, let's jump into the 5 steps that you need or go through when you build a Gen AI application. First, you need data. So there are multiple ways to collect data in Elastic. You can use our API and our clients. You can use connectors, or you can use web crawlers. You can also add privileges or privacy information to your data to make sure that only certain people can see certain fields or certain documents. So adding role-based access control in Elastic is very easy, and just to make sure that the LLM is not responding things they shouldn't know. The second step is to create embeddings, so convert the meaning of this data, of this text, into numbers, in a long list of numbers. And there are multiple ways to do this. We have some out-of-the-box options, like ELSER. It's our proprietary model. It's for English language. You can also use E5, which is available out of the box with just a few clicks. This is a multilingual model. Then you can also go for hosted options like OpenAI and Cohere, or you can use open source models. You can find an open source model on Hugging Face, upload it in Elastic, and create embeddings using that model. When you do this, you need to think about chunking your data, because these models have a limited input that they can process. So you need to think about how we can divide big chunks of data into smaller ones. So you need a chunking strategy. You can either go very granular, for example, words or sentences, or more broad, like pages and documents. So the chunking strategy depends on your data, your use case. We have a lot of cool blogs about this if you're interested. But this is really something that depends per use case and something you can test out as well. The third step is to query this data and to rank the results based on relevance. So when we have this data, we have this vector embeddings, you do the same thing with the query. You use the same model to generate a vector, and then you use vector similarity. So we use the nearest neighbor algorithm to find the most relevant vector, so the most similar result. And we know when we provide a search experience in Belgium, they might want to search in other languages. We have many languages in Belgium. I also learned that our king has many different names in all these languages. Fun fact, didn't know this. But that's why it might be important to have a search experience that can handle questions asked in a different language. So when we look at this example, which is a query for the largest ocean on Earth, we can use PM25. This is just full text search. But this won't work because it doesn't understand the meaning of this question. It will just look at these words and try to find documents that contain these words. Okay, let's look at ELSER. As I mentioned, this was built for English text. So it does work for the English query. But when you look at the Dutch one, you see grootste. So it will think you're talking about groot, which is not what we're looking for. So for other languages, this doesn't work. And that's where the E5 model comes in. This is a multilingual one I was talking about, so this works. And in Elastic, you can also easily use hybrid search, where you can combine different of these different models, or also the full text search as well. Okay, now we found the most relevant documents, and now it's time to generate the response. So this is where you will have the prompt, you have the original question, and you provide the context that you just found. You send it to an LLM, and it will respond back with the generated text. This chat application logic can use frameworks like LangChain to make it easier to chain these different commands and steps into one flow. This is an example where I ask our internal support AI assistant how to find the information of the currently logged in user. It says, okay, you need to use user_current. It also provides me with what the response will look like, but this doesn't work. It sounds believable, it looks believable, but this is not how you do it. So that's very something that you need to be careful for hallucinations. So making sure you have the right context, the right prompts to limit these hallucinations. You can also use user feedback to evaluate these models and make them better. And that's where we have step 5, where we look at observability and security. So by having insights in how these things work, we can improve them and also make sure that there's no things that we don't want to happen. One example is keeping an eye on the token consumption. So you are billed per token. The same thing you can do in Elastic. You can also have an APM kind of experience where you can see the latency and all the different steps involved in your GenAI application. And when it comes to security, you might want to check for things like when there's credentials or passwords involved and the LLM says, okay, I can't help you. You might want to know which users are trying to do prompt injection. And that's where this ESQL query comes in, which will look at logs where this has happened and alert you when it happens more than 2 times in one day. So to recap, the 5 steps. First, you need to collect the data. Then you need to create embeddings for the semantic search, finding the most relevant documents. You query it. You can also re-rank it. Make sure that you provide only the top 1, 2, 3 documents as context. Then you give it to the LLM. It will use it to generate a response. And then make sure that you have insights in what's going on, have observability and security built within your GenAI application. If you want to test it out, Elastic Cloud is available on AWS, GCP, and Azure through the marketplace. You can also use it, install it on premises, on virtual machines or Kubernetes. If you want to know more, then we have a great website called Search Labs, where we post all kinds of blogs, guides, Jupyter notebooks, examples on how to build these experiences. You can also join our free EMEA workshops. We have one June 25th about GenAI, so you can just register for free and you'll get hands-on experience. And if you want to join our Belgian Elastic community, you can scan this QR code. We will have our next meetup about GenAI, which will be June 6th at Microsoft in Brussels. Okay. So if you have any questions or if you want to know more, come by our booth or reach out to me on LinkedIn. I hope you enjoyed this session and have a great rest of the day. Thank you.